Hello, this is Justin Bader here to teach you Organic Chemistry 1, following the curriculum format as taught at MIT. This video will cover some of the materials for Exam 1. The topics include the basics, Lewis structures, degrees of unsaturation, and some structure determination examples. Lewis structures are ways to represent a molecule with bonds and atoms and lone pairs. As you can see, we have lone pairs of electrons, for example, on the oxygen here and here. We have single bonds going to hydrogens, a great way to represent molecules in space. So here we have an alkene, and an easier way to draw that, oftentimes organic chemists are lazy. They like to do just like that, which is totally correct. They don't draw the hydrogens, and they assume the carbons are basically the ends of a line, or the corners. An example to draw CH3OH for here to the right would be like that. That's how I prefer to do it. Some chemists like to draw the group like that, or you can also write it like that. All three of those are correct. They're all the same thing. They're just different ways of writing it. I usually prefer to write the first one just because I'm lazy and I don't like to write out everything. But they're all correct. For example, this one over here we could draw like that. Wedges and hash structures. The wedges signify that the atom is coming out of the plane of the page, whereas the hashes signify that the atom is going into the plane of the page. The regular lines that we drew in the previous examples would show that that the atoms are in the plane of the page. So, for example, this wedge right here is actually coming out at you, and that means the hydrogen's coming out. The hydrogen right here is coming out of the plane of the page. Like I said, they use these to show the differences between two-dimensional and three-dimensional structures. It's very important for stereochemistry, as we'll cover in the next video. And you need to make sure you read the instructions and directions, because sometimes stereochemistry is very important. In fact, stereochemistry is pretty much always important, so I would always defer to using the wedge and hash instead of doing the two-dimensional way. The degrees of unsaturation are very important for organic chemistry. They have a lot of uses that we'll discuss later, but for now, in order to calculate the degrees of unsaturation, you need to add up the number of pi bonds in the molecule and the number of rings in the molecule. Please note that a double bond is equal to 1 pi bond, and a triple bond is equal to 2 pi bonds. So we would look at this molecule here, and we would see that there are 1, 2, 3, 4, 5, 6 pi bonds. So we would say there are 6 pi bonds. And how many rings are present? Well, we would see there's 1 ring there, 1 ring there, and 1 ring there. So there are 3. There are 3 rings. So we would add those up, and degrees of unsaturation would be 9. There is a handy formula that you can use to calculate the degrees of unsaturation. This is very crucial when you're not given the structure and you're only given the molecular formula. So the formula for the degrees of unsaturation is 2 times the number of carbons plus 2 minus the number of hydrogens minus the number of halogens, such as chlorine, fluorine, bromine, iodine, and so on, plus n, divided by 2. So let's do an example. We'll do an example for the exact same molecule we did earlier. This is the formula here on the right, and what we're going to do is we're going to do 2 times the number of carbons plus 2 minus the number of hydrogens plus the number of nitrogens divided by 2. We do the math, we go 32, 34, 36, minus 18. 18 divided by 2 is 9. So we get 9 for the degrees of saturation. This can be very important when we're doing structure determination. For example, let's try to draw the structure of C2H4O2 with at least 1 carbonyl present in the molecule. So what we'll do is we're going to do the math to find the degrees of unsaturation. So we're going to go 2 times 2 plus 2 minus 4 divided by 2. Notice how the number of oxygens do not affect the degrees of unsaturation. So that's very important. 2 times 2 plus 2 minus 4 divided by 2 is 1. So there's going to be 1 degree of unsaturation. And notice that there is at least 1 carbonyl. That means we're going to have carbonyl, if you recall, is a double bond O attached to a carbon. And a carbon can have a variation of groups. So one of the answers with C2H4O2 would be this. And then we can always check our work by counting the number of hydrogens, 4. And we see there are 3 hydrogens here. There's 1 hydrogen here, that's 4. 2 oxygens and 2 carbons, so we are done. There are multiple answers for this question, but this is the most common and realistic structure. Thank you for watching. This, like I said, is part 1 of Exam 1 tutorial for Organic Chemistry 1 at MIT. This material here was rather basic, but the videos in the upcoming videos, I guess, are going to be much more intense and include a lot more information that you'll definitely want to know if you want to get an A in 512 Organic Chemistry 1. Thanks for watching.